Today I'm going to talk about conditional probability and the multiplication rule. First of all, conditional probability just means that you're looking for the probability of some event occurring given that some other event has already occurred. And the notation that we'll use is P of, in parentheses, event B given event A. And notice the vertical bar between the two. The probability of B given A. So assume that we have two cards that we're picking out of a standard deck. And what we want to find is the probability that the second card we pick is a queen if the first card has been a king. And we assume that the king is not being replaced in the deck. So the probability of event B, which is queen, given event A, which is king, is going to be 4 out of 51. And the reason is that there are still 4 queens in the deck, but there are now only 51 cards in the deck because you've removed one. So the probability of the second card being a queen, given that the first card is a king, is 4 out of 51, or 0.078. We have two different kinds of events. Some events are independent and some events are dependent. So if you have independent events, then the occurrence of one of the events doesn't affect the probability of the other one, and therefore the P of B given A would be equal to P of B, or the P of A given B would be equal to the P of A. All right, and events that aren't independent, of course, are going to be dependent. Let's look at an example. All right, if you are selecting a king from a standard deck of cards, not replacing it, and then selecting a queen from the deck, would this be a dependent event, picking a queen, or would it be an independent event? Well, let's look at the solution. The probability that the second card is a queen, given that the first card is a king, would be 4 out of 51. And yet the probability of drawing a queen out of the full deck would be 4 out of 52. And therefore, these two events are dependent. The occurrence of A, that is drawing a king, changes the probability of drawing a queen out of that deck because you didn't replace the first card. All right, suppose we toss a coin and we get a head. That would be event A. And then we roll a 6-sided die and we get a 6. That would be event B. Now, these two events are going to be independent, and I think that's pretty obvious. The probability of rolling a 6, given that you have a head on the coin, is 1 out of 6, because you're rolling the die. You haven't done anything with the die already, so you have 1 chance out of 6 of getting a 6 on that die. The probability of B, without even thinking about the coin, would also be 1 out of 6, and therefore the occurrence of A does not change the probability of B, and these are independent events. The multiplication rule for the probability of A and B. The probability that two events will occur in sequence, one after the other, probability of A and B, is going to be equal to the probability of A times the probability of B given A. For independent events, of course, the probability of A and B is simply going to be the product of the two individual probabilities. All right, so you have to stop and think when you're applying the multiplication rule if these events are dependent or independent. Let's talk about finding the probability that a randomly selected senior was matched with a residency position and it was one of the senior's top 2 choices. Okay, you're going away to college. So A is the event that you're matched to the residence that you wanted. And B is the probability that you're matched to one of the top 2 choices. So the probability of A we're given is 0.93, that you're actually going to be matched, you're going to be accepted for residency. The probability of B given A is 0.82. All right, you've been accepted for residency. Now what's the probability you'll get one of your top two choices? So these are dependent events. B occurring certainly depends upon the fact that you've already been accepted for residency. So the events are dependent, and therefore the probability of A and B is the probability of A, which is 0.93, times the probability of B given A, which is 0.82, or 0.763. All right, now let's find the probability that a randomly selected senior that was matched or accepted for residency did not get matched with one of the top two choices. And here we can just simply use the complement. We know that the probability of B given A from the previous example is 0.82, and therefore the probability of the complement, not B given A, is going to be 1 minus 0.82, or 0.18. Be sure you have a good understanding of the complement, because that's going to be pretty important as you are solving these probability problems. Okay, good luck with conditional probability.